Welcome back to our series of solution and explanation to competitive coding. Today we are going to solve LeetCode question number 100, that is same tree. So let me read the question to understand what the question says. Okay, so we are initially given the roots of two binary trees P and Q, write a function to check if they are same or not. Okay, so we are given like roots of two binary trees and we have to tell whether they're same or not and at what parameters we can measure whether they are same or not. So two binary trees are considered the same if they are structurally identical and nodes have same values. Okay, so it says that to be two binary trees to be same, they should be, first thing is that they should be structurally same. So how can we check whether they are structurally same or not? We can say if two binary trees are structurally same, but if all the nodes in the tree have the like same left and right child, like if one tree has, for any node, if one tree has left and right child, the other should also, the node of other tree should also have left and right child for the respective node. And if one tree has, like for any particular node, if one tree has left child, so other should also have left. If one tree has only right, so other should also have only right. Then they are called structurally same. And the other condition, the next condition is that for the tree to be same, that all the respective nodes should have same values. Like if its root have one value as one, it's the root of other should also have value as one. And if left child of root has value 2, so the other tree should also have its left child should be also have value as 2. Okay, if its right child of tree or root have value 3, so the node of other tree left right node should also have value 3. Okay, so they have like similar values. Okay, so like in the example number 1, they are like same trees because they are identical in structure and all the respective nodes have same values, and so we have to return true because they are same trees. In example number 2, we are given a tree which both of trees have same values as their root and child, but they are not like structurally identical because its node, root node has left child and doesn't have right child, but the other tree has its root with right child and doesn't have left child. So they are not like structurally same. And for the third example, though they are structurally same, but their respective nodes don't have same values. Like here, left child have 2 as a value and right child like for the other tree is one as their left one as the value of left child, and for the right child value of first tree is 1, and for the right child value of second tree is 2. So we have given constraints like number of nodes in both the trees is in range 0 to 100. Both the trees could have something nodes between 0 to 100, like they could have 0 or 100 nodes and something between them. Okay, and the value of nodes would be something like 10 to the power minus 10 to the power 4 to 10 to the power 4. That's not our deal. That's not a big deal. Okay, so let us understand how the node of a binary tree is structured. So like node of a binary tree has some initial like integer value, and it has some value for left child, like a pointer or reference to left child, and it has pointer or reference to right child, and it has one constructor which is only used to initialize the value. It can initialize the value, and it has another constructor which can initialize value as well as both the left and right child. Okay, so this is the structure of our node of a binary tree. Okay, so let's go and check how can we solve this. So suppose this is our example number 1, and we have two trees and we have to check if they are same or not. So what we have to do is we have to follow simple 3 steps, and then we can recursively call with either BFS or DFS something to check if like two trees are same or not. So 3 steps, what we have to follow is first we have to check if both the trees are empty, because if both the trees are empty, they are identical because there is nothing in both the trees, so they are considered to be identical. Okay, so first thing we are going to check if both the trees are empty. So if suppose this is our P tree and this is our Q tree, And so what we are going to do is check if both are empty. So we are given the reference, or the okay, the reference is root. So we are going to check if root is empty, and we find it is not empty, and we have to check it for both the trees, and we found both are not empty. And then second condition is that if like one tree is empty and other is not empty, so what we are going to do, we have to return false, because they are not structurally identical, because one is empty and other is not empty. Okay, so second is we have to do check whether one of them is empty and other is not. So we are going to return false. Either it could be P could be empty, or and Q could have some value, or Q could be empty and P could have some values. If this is the condition, we have to return false. So this is second condition. First is if both are empty, then we have to return true. If one is empty, we have to return false. The third condition is if the value of any of, like if the value of nodes are not equal. Suppose its root has 3 and it also have 3. If they are not equal, then we are going to return again false. Why? Because then they don't have same values, so they are not same trees. Okay, so for this tree, if we check if they are empty, both are empty, no. If one of them is empty and other is not empty, no. And the third condition, if the values they hold are different, no, because they both have same values. Then what we are going to do, if all three conditions are met, then we are going to recursively call their left and right child to traverse whole the tree. So we are going to call left child and apply all three conditions for both of the left of for both the trees, for like left child of both the trees, and we are going to check all three conditions, like if both are empty, no. If one of them is empty, other is not empty, again no. And if values of the nodes are not same, no, because they have same value. Then we are again going to go for its left, and we found if both are empty, yeah, so we have to return true, and we come back and call its right. Then we check if they both are empty, then yeah, again both are empty. Then we are done with its left. Then we have to go for like roots right, and again check all the conditions. If both are null, no. If like one of them is null and the other is not null, again no. And if the values they hold are not similar, again no, because they have similar values. Then what we are going to do is we have to again go for their left child, and we reach this node for this tree, and here is some null value stored because it doesn't have like left child. So what we are going to do, again we have to check if both are empty, no, because one has some value. If one of them is empty and other is not empty, yeah, this one is empty, like this one is empty and this one is not empty, so we have to directly return false, and we don't have to do any other further calculations because they are not structurally same. So this is one example. Our second example is if like for the value difference. Okay, so for this again we are going to apply all three conditions. If both are null, no. If one of them is null, no, again no. And if the values they hold are different, again we have to say no. We keep on going, checking all three conditions for all the nodes. If this node done pretty well, they are identical. This node also done pretty well, they are identical. But when we go for this, if we check if both are null, they are not. And when we check if one of them is null, again they are not. But when we go to check that if the values are same or not, then we found that their values are not same, then we have to return false because they can't be same if they have different values for respective nodes. So our last example is that, okay, so in this again we are going to apply all the three conditions. We reach the node, and we found check all the three conditions. If both are null, we found they are not null. We check if one of them is empty and other is not, again we found no. And we check if their values are not same, again we say they have same value. So we have to iteratively call their recursively call left and right child. So we again apply all the conditions for left child, we found they are same, and again we call recursively left child, we found same. So we are doing it in DFS manner. We go for its right, we found they are same, and we are done with the left of root, and then we move to right of root. Again we do for like right of root, we found all the three conditions are met. Again we go for left, and we found there is nothing. And for a second tree there isn't anything. And we again go for right, and we found they met all three conditions. Then we have to finally return true for this tree. Okay, so let me code what we have understood up till now, so that you can get a better idea. So the first condition we are checking is if both are null, we have to return true. If like p equals null, and like if both are null, q equals null, then we are going to return true. Okay, so we have to simply return true. Okay, this is the first condition we are going to check, and second condition is if one of them is null and other is not, we are going to return false. Okay, if like p is null, p equals null, and q is not null, and q is not equals null, or the condition could be reversed, like if p is not null and q is null. If p is not equals null and if q is equals to null, then what we are going to return is false. Simply return false. Okay, so our third condition is that we are going to check if the value of their nodes are not same. So third condition is if p.val is not equals to q.val, we are simply going to return false. Return false. If all the three conditions are met, then we are going to recursively call, like for left and right child. Okay, if all the conditions, then we can return like okay, we have to call the function is same function is same tree. Okay, and we are going to call for its left and right. We can do is that p dot left comma q dot left, and we have to check for right also. So we are going to check for right is same, my bad, I missed same tree. Okay, and then we are going to check for right. Okay, p dot right comma q dot right. Okay, so let me check if it works or not. We are doing DFS. Okay, it seems to work. Let me submit if it is like valid for all cases and if it is optimal or not. So it seems to work properly, and it is kind of like 100% faster, so we are not using much of like time, but it's showing that we are using some of the space for even MB. So that's not a bad solution for time, but for space it is quite bad solution. But we hope you understand the concepts and enjoy learning. And if you have better solutions, you can comment in the comment section down below. And as always, thanks for watching.